Good morning, dear students. How are you? Today we have a new chapter about trigonometry. So, what's the trigonometry? It's one of the important branches in the history of mathematics, and this concept is given by the Greek mathematician Hipparchus. Basically, it's the study of triangles where we deal with the angles and the sides of the triangle. To be more specific, it's all about the right angle triangle. It's one of those divisions in mathematics that helps in finding the angles and the missing sides of a triangle by the help of trigonometric ratios. The angles are either measured in radians or degrees. The usual trigonometry angles are 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree, which are commonly used. In this branch divides into two sub-branches are called trigonometric, plane trigonometry and spherical geometry. Here in this theory, we'll learn about the trigonometric ratios of right angle triangle. Now I'll open presentation. Okay, this is silly old horse. I will introduce with him at the end of the lesson. First of all, let's warming up by solving the equations below. In first question, x is equal to 40. Yes. In the second equation, x is equal to 45. In the third equation, x is equal to 4. In the fourth, x is equal to 3, and at the last equation, x is equal to 4. Very good. Let's talk about the trigonometry. We can use trigonometry to find the missing angles and the length of triangle. Trigonometry uses main three functions. These are called sine, cosine, and the tangent functions. We'll start working with the right angle triangle. First of all, we must label the side of this right angle triangle. It's very important. Here, the long side and the opposite side to the right angle, call it the hypotenuse. What about the two other sides? Before to label these two other sides, we must take the angle. If we are giving this angle, we label as the sides like this. This will be adjacent side, and this will be opposite side. If we take this angle, so our sides will be like this. This will be the adjacent side, and this will be the opposite side to this angle. Okay, let's continue. If you understand the labeling, let's choose the 10 multiple choice questions about the labeling right angle triangle. First of all, first question is, what is the side marked with an X? Here we have the right angle triangle, we have the angle theta, and we must find the X side. It's the opposite side to the angle theta, yes? So X is opposite. Okay. Next question, what is the side marked with an X? Here also we have the right angle triangle, the angle theta, and this X side, and it's the adjacent side to the angle theta. Okay, next question. Here we must find the X side. It's the long side, it's opposite to the right angle, so X is hypotenuse. Okay, what is the side marked with an X? Here X is opposite. Okay, here X is hypotenuse. Here X is adjacent side. The next question, X is also adjacent side. Let's see, here X is opposite side. Here X is also opposite side. And the last question, X is hypotenuse. I think you understand the subtopic about the labeling side of the right angle triangle. Okay, let's talk about the rule of the main functions. First, we'll start about the sine rule. We use sine when we have the opposite length and the hypotenuse. Here, sine 30 degree is equal to 5 over 10 opposite side over hypotenuse. So you know that the sine 30 degree is equal to 1 over 2, and we get it from this ratio. 5 over 10 will be 1 over 2. So Let's do some examples about the sine rule. Here we have right angle triangle, and one angel's measure is 42 degree, hypotenuse is equal to 7 cm, and the missing side is opposite side to this angle. So we will use the sine rule, which is sine theta is equal to opposite side over hypotenuse side. We know the sine 42 degrees, we know the hypotenuse, but we don't know about the opposite. So sine 42 degree is equal to O over 7. Here O is equal to 7 times sine 42 degree, and to learn the value of the sine 42 degree, we will use trigonometry calculator, and we times its value by the 7 and get the length of the opposite side, and it's equal to 4.68 cm. Okay, let's continue. Another example. Here, missing side is hypotenuse. We know the measure of the angle, we know the opposite side's length, and by using the sine rule, we must find the hypotenuse. So hypotenuse will be here. Hypotenuse will be 10 over sine 70 degree. Yes, hypotenuse is equal to 10 over sine 70 degree, and it's equal to 34.2 cm. Let's continue. Second main function is cosine function, and we have the cosine rule. We use cosine when we have the adjacent planes and the hypotenuse. We can measure the angles of degree of angle between them. So cosine theta will be equal to adjacent side over hypotenuse. Let's do some examples. Here we have the measure of the angle, we have the length of the hypotenuse, we must find the length of the adjacent side. So our rule is like this. So cosine 53 degree will be equal to A over 9, yes? So A will be equal to 9 times cosine 53 degree, and it's equal to 5.42 cm. Next example, here missing side is hypotenuse. By using cosine rule, we can easily find this hypotenuse. It will be like this: cosine 70 degree is equal to adjacent side over hypotenuse. Yes, 9 over h, and h will be equal to 9 over cosine 70 degrees, and it's equal to 9.41 cm. Let's talk about the tangent rule. We use tangent when we have the opposite and the adjacent lengths here. This is the adjacent length, this is the opposite side's length, 10 cm. And we can easily find the measure of this angle. Tangent theta will be equal to opposite side over adjacent side. Let's do some examples. Here we must find the adjacent side O. We use tangent rule, whereas the tangent 33 degree will be O over 11, yes? Or 11, and here O is equal to 11 times tangent 53 degree, and O is equal to 14.6 cm. Next. So here we have the three rules. The sine theta is equal to opposite side over hypotenuse, cosine theta is equal to adjacent side over hypotenuse, and the tangent theta is equal to opposite side over adjacent. Shortly, we can write it like this: sine theta over O, sine theta is equal to O over H, and so on. If we take its main letters, we get the word like sohkahtoa. There are a few ways to remember this easily. Silly old horse can't always hear the other animals. Silly old horse can always hear the other animals. Yes, as I said, I promised you to introduce with this horse you, and it's a silly old horse that is can't always hear the other animals. Here we have some practice problems. It will be your homework. I will send you it by EduPage. So this is the end of our lesson. Thank you for your attention. See you. Goodbye.